everybody. In this video, we're going to be talking about mental math strategies that you can teach your students for adding and subtracting rational numbers. So, a couple of these strategies come from the properties of addition. So, the commutative property for whole numbers basically says that, like, if you have 3 plus 2, that's the same thing as 2 plus 3. And the same thing applies when you're adding fractional numbers or decimal numbers. Then there's the associative property, which says that if you add numbers, basically that you can add numbers in any order. So, like if I was trying to add 1 plus 2 plus 3, I could either add it as 1 plus 2 and then add the 3 to get 6, or I could do 2 plus 3 and then add the 1 to get 6. So that's the associative property. And then the identity property says that any number plus 0 will equal itself. So we could use the commutative and associative properties to make our addition problems a little bit easier when we're adding and subtracting fractions and decimals. So for example, if I had 2 sevenths plus 3 fifths plus 5 sevenths, I may want to use the associative property to rethink about this problem as 2 sevenths plus 5 sevenths, plus 3 fifths like this. So basically, I'm just switching these two spots, and you can teach your kids how to do this mentally. But the reason this would be useful is because if I do 2 sevenths plus 5 sevenths, I get 7 sevenths, which is a whole. And that means that my answer is 1 and 3 fifths. And notice that I never had to find common denominators because the fractions I was given were convenient enough that I could just add them together to make a whole number. So obviously, you would have to plan your problems in advance to make sure they actually did that. But variations of this can still be helpful because oftentimes it's easier to combine all of the fractions with the same denominator first and then find common denominators from there, even if it doesn't simplify to be a whole. With decimals, you could do something similar. So I noticed that these two decimals are hundredths, while this one is a thousandths, like that's their smallest place value. So I might rearrange these and add these together first, because I could say, well, if I have 58 hundredths plus 21 hundredths, that's just going to be 79 hundredths. So I would have 79 hundredths, and then the whole numbers, if I add those together, 3 plus 15 is 18. So I would have 18 and 79 hundredths plus 2 and 19 thousandths. And then from there, I can just add together my place values and I can say, okay, well, 18 plus 2 equals 20. 7 tenths plus no tenths equals 7 tenths. 9 hundredths plus 100 gives me 10 hundredths, which means that this 7 will actually be an 8 because I'll exchange the 10 hundredths for a tenth and I will have 0 hundredths. And then the 9 thousandths will just be 9 thousandths. And so that's one way that I could solve this one. Notice in this case that I added from left to right. That's another mental math strategy you can teach your students. Just keep in mind that you may need to adjust your answer like I did. Like I said, 7 tenths plus 0 tenths is 7 tenths. But then I realized that my 9 hundredths plus my 100th would give me 10 hundredths, which is the same thing as a tenth. So sometimes you'll need to adjust that if you add from left to right. But it can be helpful because that's the order we write in. And it's not usually that hard to adjust it if you need to. Another strategy that you can use is called additive compensation. So the idea of additive compensation is that you take some of one of the numbers and combine it with the other number to make a number that's either like a place value or a whole number or something that's easy to add. So, for example, if we were adding the whole numbers 8 and 6, additive compensation would look like thinking about it as 8 plus 2 plus 4, so that you can add the 8 and the 2 together to get 10, and then when you add 4, you get 14. So you don't actually write this out, it's more of like a thinking strategy. But basically, you're saying, like, okay, to get from 8 to the number 10, which is the next place value, how much do I need to add to 8? Well, I just need to add 2. So I'll take 2 from the 6, which leaves me with 4. And so the 8 plus the 2 will give me 10, and then plus the extra 4 gives me the 14. So that's what it looks like with whole numbers. And you can do the same thing with decimal numbers. So with decimal numbers, I might say, okay, what do I need to get from 5.68 to the whole number 6? Because that would be really easy to add. And I'd say, okay, well, the 8 is going to need a 2. And then when I combine those together, that will make a tenth. So I'll have 7/10. And then I'll need 3 more tenths to make a whole number, which will give me 6 wholes. So I need 32 hundredths. That's what I need to add to 68 hundredths to make a whole number. So I'm going to take away 32 hundredths from this one, and that will give me the decimal part of my answer. Because if I take 32 hundredths from this number and combine it over here, whatever's left over will be the decimal part of my answer. So I'll say, okay, well, there's 1 hundredth and 2 tenths. And then for my whole numbers, I'm going to say, okay, well, I had my 5 whole numbers here. And then I had the one whole number that I got when I took 32 from this decimal and combined it with this decimal. So that's 6 whole numbers. And when I add that to 7, that gives me 13. And so my answer is 13.21. And eventually you'll want your students to get to the point where they can do this process in their head. But I wanted to kind of write it out to you so that you could kind of see how it works. You can do the same thing with fractions. So, for example, if you had 1/2 plus 3/4, you can actually use either number, whichever one you think would be easiest. So, I might say, okay, I want to make 3/4 into a whole number. So, how much do I need to make it a whole number? Well, I need 1/4. So, I'll take away a fourth from the 1/2, which leaves me with 1/4. So, that will be the fractional part. And when I take away a fourth from a half and combine it with the 3/4, that makes 1 whole. And that's how additive compensation works. Um, and again, you won't always use all of these, but it's helpful for your students to know them so that they can practice using them when they need to do mental math. So that's additive compensation. The other mental math strategy that you can teach your students is the idea of equal additions. So, the idea of equal additions is that you add the same thing to both parts that you're subtracting, and it won't end up changing the answer. And to show your students that this really works, you can give them a few examples. Like you can say, okay, 5 minus 3, we know that this equals 2. But what happens if I add maybe 10 to both of these? Well, if I do 15 minus 13, the answer is still 2. What if I add, I don't know, 7 to them? Well, 5 plus 7 is 12. 3 plus 7 is 10. Again, it doesn't change the answer at all. So, regardless of what you add to both parts, if you add it the same number to both parts of the subtraction, your answer won't change at all. And so, what you want to do is you want to add something that makes it easy for you to calculate it. So, with whole numbers, it might look something like this, where you add 1 to both of these numbers because then you'll be solving 88 minus 50, which is really easy to answer. That's just 38. And then with decimals, you can do something similar and you can say, okay, well, what would make this number really easy to subtract? Well, if it was the number 6, that would make it really easy. So I'm going to add 2 thousandths to make the 8 plus 2 thousandths become 10 thousandths, which is 100. And when I combine that 100th with the 400, that would give me 500. So I'm going to add another 500ths. And when I add all of that stuff together, that will give me a tenth. And that 1/10 plus the 9 tenths will give me the number 6. So I'm going to add 0.052 to both of these decimals. And when I do that, that gives me the decimal 7.192 minus 6. Well, that's really easy to subtract because 7.192 minus 6 is just going to be 1.192. And so that's the mental math strategy you could use for decimals. And for fractions, you could do something similar where you could say, okay, I want to add 3/8 to both sides. And 1/2 is a really easy number to add with, especially if the denominator of the other number is even. And so you'd say, well, 1/2 is 4/8. So if I add 3/8, that's going to be 9 and 7/8 minus, if I have 3 and 5/8 plus 3/8, that's going to be 3 and 8/8, which is the number 4. And so I get 9 and 7/8 minus 4, which will be 5 and 7/8. And so that's how subtractive compensation works. So to summarize, you can use the commutative and associative properties to rearrange the addition in whatever order you think would be easiest to add mentally. You can use additive compensation, which is where you take one of your numbers and you split it up into pieces that make it easy to add to the other number. And then you combine the results. And then with subtractive compensation, this works with subtraction. That's when you add the same thing to both parts that you're subtracting. And then that makes the subtraction process easier. So if you have any questions about these mental math strategies, let me know. And I hope that you guys have a great day.